In the name of Allah, the Compassionate and the Merciful. Hello guys, my name is Salar Dilaver Qashqai, and in this video we're going to have an example about free vibration analysis of single degree of freedom spring in OpenSees. You see guys, in here we have single degree of freedom spring with initial conditions as a initial displacement, and based on time history loading and initial displacement, we are going to run 6 different conditions analyzing of this free vibration analysis. So let's see the examples. So you see in here we have 6 different kinds of free vibration analysis. With at the first we are going to run the free vibration analysis with elastic spring. In second analysis we are going to run the free vibration analysis with an elastic spring, and in third analysis we are going to run the inelastic spring with trigonometric loading as the OpenSees properties time series. In the fourth analysis we are going to run the free vibration analysis of inelastic spring with triangular loading. In the fifth analysis we are going to run the free vibration analysis of inelastic spring with rectangular loading, and also at the sixth analysis we are going to run the free vibration analysis of inelastic spring with the pulse loading. So you see guys, with this 4 time series analysis we are going to apply the loading time history and then seeing the result. So at the first we are going to apply the initial displacement, then applying the loads for this 4th analysis loading conditions as a time history analysis. So triangular time series as OpenSees property, it has this shape, and also rectangular time history has this shape, and also triangular time series has this shape, and also pulse time history has this shape, and also time start and time end, and also periods. You see, for this most of these time series has the same properties, and then we are going to run these 6 different free vibration analysis conditions and seeing the results. So let's see the OpenSees file code. So in first example we are going to see the codes of the free vibration analysis of elastic spring. So in here we're going to define the elastic spring element as a truss element, and then defining the model of elasticity, cross sections, area, length, and mass, and also initial displacement and damping ratios for this OpenSees file, and defining the nodes, conditions, boundary conditions, defining the mass, and also defining the elastic material. So because we in first analysis we have a elastic spring element, so linear relations between force and displacements we have in this example, and also defining the loads, and also applying the initial displacement, and then running the dynamic analysis with Newton method as algorithm, and Newmark method for this numerical method solving the equations, and also defining the mass damping ratios in here, and solving the Rayleigh damping ratios. And also in here we're going to run and outputting two conditions, undamped conditions and damped conditions. You see guys in here? And then we're going to plot and see the different results for displacement, for undamped and damped conditions, for this elastic spring with initial displacement. You see guys in here? So let's see. Initial displacements start from 0.001, so you see, and in damped spring we have in each time the displacement is going to be less than last data. So, and also you see the velocity time history and also acceleration time history and also spring force time history analysis. So let's see the second analysis. In the second analysis, we're going to run the free vibration analysis with inelastic spring. So linear, non-linear relations between force and displacement with defining the material property is going to be calculated and shown. So in here, all the parameters is the same as mass and length, and also in here we're going to define the spring nonlinear properties. So I define these properties, you see guys in here, and we're going to run and define these materials for these inelastic properties, and also defining the truss element as same as last analysis. And let's see, all process is the same, and you see guys in here, and also we're going to output undamped and damped time history analysis of velocity, acceleration, displacement, and also reactions. You see guys in here, time history, velocity, accelerations, and also spring force is going to be calculated and shown. So in third analysis, we're going to run the free vibration analysis of inelastic spring with trigonometric loading. So let's see the trigonometric loading as OpenSees time series command. You see in here with this formula and these properties. We're going to run it and seeing the results of this analysis. All the input data is the same, and you see in trigonometric loading we're going to define the start time and end time and also period and load factors for this analysis, for this definition, and also we defined the inelastic properties for the spring. And also in here you see in time history analysis we are going to define it and run the dynamic analysis. Our process is the same, and then calculating the undamped and damped conditions. You see guys in here. So at the first we are going to apply the initial displacement, then applying the load time history. You see guys in here it has displacement and velocity, accelerations, and spring force time history results. So in a fourth analysis we're going to run the free vibration analysis with inelastic spring with triangular loading. You see guys in here. So in OpenSees properties time series of this rectangular time series, it has this shape. You see guys in here, and you can see the different properties, and we're going to define it. You see guys in here all the input data is the same, and in triangle loading parameters is the same as last analysis. And let's see in here, yeah, in here we're going to define it as a triangular time history loading, and running the dynamic analysis, and you see time history, velocity, and accelerations and spring force for undamped and damped conditions with initial displacement and time force time history analysis of this conditional loading for this triangular loading is going to be calculated and shown. So let's see the other analysis. So in fifth analysis, we are going to run the free vibration analysis of inelastic spring with rectangular loading. So you see in here rectangular time series loading parameters for OpenSees. You see, guys, you must define these properties and run the time series analysis for this analysis. So all input data as same as others, and in here we are going to define the parameters for this rectangular loading. You see all the coefficients is the same as last analysis data, and then in here we are going to define the inelastic properties and also running the newmark and as a numerical methods for dynamic analysis and algorithms for solving the equations as a Newton, and also outputting the displacement, velocity, acceleration, and spring force, and outputting the undamped and damped conditions for these two kind of analysis reported for velocity, accelerations, and displacement and spring forces. You see, guys, in here. So at the last analysis, as a fixed analysis, we are going to run the free vibration analysis of inelastic spring with pulse loading. So in here you see the pulse time series as OpenSees properties, and we're going to define these properties for this time series analysis and run it. See, guys, in here. So in pulse loading with inelastic spring, you see, guys, all the input data is the same, and also in pulse loading parameters is the same as others, but in here we're going to define the pulse width for this input analysis. So pulse width comes from, you see, in here you see pulse width is going to, it must be defined. Pulse width, you see, guys, yeah. So pulse width is defined at 2.5 seconds, and in here we're going to run the dynamic analysis with inelastic materials properties of this truss element, and also running the this dynamic analysis, and then outputting the velocity, acceleration, and spring force outputted data for undamped and damped conditions. You see in here different results of this velocity, acceleration, and spring force of this pulse loading conditions going to be calculated and shown. So thanks, guys. These videos which I prepared just for educational purpose. Please have a comment and even email me to tell me know about this kind of modeling. God bless you guys. Bye.